Hi everyone, today we are going to learn about linear inequalities and absolute value inequalities. Solving an inequality is the process of finding the set of the numbers that make the inequality a true statement. We called these numbers as solutions of the inequality, and this solution should satisfy the inequality. First, let's learn about interval notation. There are three types of intervals: open interval, closed interval, and infinite interval. What is the open interval? To denote open interval, we use parentheses. Inside the parentheses, we write two numbers, real numbers a, b, which means this interval includes set of real numbers between a and b but not includes a and b to the interval. That is the meaning of open interval. So in mathematical notation, we represent open interval AB like this. All the values in between a and b but not include a and b. That is why you don't see here equal sign. So next type is a closed interval. To denote open interval, we used parentheses. Now we use square brackets to denote closed interval. Closed interval represents the set of all real numbers in between a and b, including a and b. In mathematically, we can represent it like this. Here look, in open interval, we don't have equal sign, but in closed interval, we have equal sign here. So the next type is infinite interval. Infinite interval represents the set of real numbers that are greater than a. Set of real numbers that are greater than a. Which means if you put inside the parentheses a and infinity, which means x is greater than a but not equal to a. But what happens if you use square bracket in after the b, which means here this notation represents the set of real numbers that are less than or equal to b. Here for the interval b is included. That is why we used square bracket. But here we use parentheses, then a is not belong to the interval. There are some important points about interval notation. First one is we use parentheses when endpoints not included to the interval. We used parentheses when endpoint not include to the interval. And we use square brackets to indicate endpoints that are included in an open interval. And we never use square brackets with infinity or negative infinity. We always use parentheses with infinity or negative infinity. Now let's look at some examples using interval notation. How we express the interval in set builder notation and a graph. Here we have closed interval because here we have square brackets. So mathematically we can write it like this. Then first draw the real number line and mark the numbers. Here you can say I divided real number line in some partition, then mark the numbers. Then first I put square bracket in 1 and then in 3, then I mark this area. So this is how we express the interval in a set builder notation and graph. Then as a second example, it is an open interval which is include all the data points less than -1. In this interval, -1 is not a point. Now let's draw a graph. Again, draw a real number line. Then mark the values. Then mark -1. Here we use parentheses because we have parentheses here. Then mark all the values which is less than -1, which is less than -1. Right. Then let's move to the next section, finding intersections and unions of two intervals. These are the steps. First one, graph each interval on a number line. Then to find the intersection, take the portion of the number line that the two graphs have in common. To find the union, take the portion of the number line representing the total collection of numbers in the two graphs. So let's look at example. Here it says use graph to find the set, this set, to find this set. This is closed interval. This is open interval. We have to find intersection of these two intervals. This sign denotes the intersection. First graph closed interval. If you graph this interval, it looks like this. Then mark 1, mark 3 and shade the area in between 1 and 3. Then graph open interval 2, 4. Mark 2, mark 3 and shade the area. Then we need to look at what are the numbers in these two areas. What are the common numbers? You know, in between these two areas, 3 and 4 is the common numbers. We can write this as like this by using interval notation. So if you mark in the graph it will look like this. If you mark in the graph, it will look like this. Then let's move to the solving linear inequalities in one variable. Linear inequality in X can be written as following forms: ax plus b less than 0, ax plus b greater than 0, or ax plus b less than or equal to 0, ax plus b greater than or equal to 0. Generally, remember, if you multiply or divide both sides of an inequality by a negative number, then the direction of the inequality symbol will change. Think if you multiply this by -1, the sign will change to this one. The sign will change. Let's consider example to solve the linear inequality. The inequality is 2 minus 3x less than or equal 5. Then take all the x terms into one side and in the other side put remaining numbers. You can simplify here like this. Look at, in this step we divide both sides by -3. So the sign is changed. Here we have less than or equal. Here we have greater than or equal. So the solution set is x is greater than or equal -1. We can rewrite this by using interval notation. Here -1 is in our solution set. That is why we used square bracket here. So if you denote this interval in a number line graph, it will look like this. All the values greater than -1. All the values greater than -1. Here we mark greater than. Here we marked -1 here. We used square bracket and then shaded this area which is greater than -1. Let's look at another example. Here it says solve the inequality 3 times x plus 1 greater than 3x plus 2. Take all the x terms into one side and simplify. First, simplify brackets. It gives 3 times x plus 3 greater than or equal. Sorry, here the sign is only greater than 3x plus 3 greater than 3x plus 2. Then you will have 3 greater than 2. We know that this is always true. So how we write the solution set? Look at here. The inequality is true for all values of x. So the solution set include all the real numbers in between -infinity and positive infinity. In set build notation, you can write it like this. Then let's look at how to solve a compound inequality. Here you have two inequality signs. 2x plus 3 should be greater than or equal 1 or less than 11. Our goal is isolate x in the middle. To isolate x, first you need to remove these 3. To remove these 3, subtract 3 from each term in the inequality. Make sure subtract -3 from each term in the inequality. And you will have -2 greater than 2x greater than or equal to -2 and less than 8. If you divide this by 2, you will have x is greater than or equal to -1 or less than 4. In interval notation, you can write this like this. And if you use set builder notation, you can write the solution like this. And here the number line graph. Here the number line graph. So this is how we solve the compound inequality. Now let's learn how to solve absolute value inequality. If U is an algebraic expression and C is a positive number, the solution of absolute value of U less than C should satisfy this equation. U is greater than -C, less than C. If the absolute value of U greater than C, then the numbers should satisfy U less than -C or U greater than C. Right? Solution of absolute value U less than C should satisfy the numbers U is greater than -C, less than C. The solution of absolute value U greater than C are the numbers that satisfy U less than -C or U greater than C. These rules are valid if less than sign replaced by less than or equal and greater than sign is replaced by greater than or equal. So let's consider example about solving an absolute value inequality. So the example says solve and graph the solution set on a number line. Absolute value of 6 minus 3x greater than 18. You know that this can be rewrite like this: 6 minus 3x less than -18 or 6 minus 3x greater than 18. If we solve first inequality, as an answer you will have x greater than 8. If you solve second inequality, you will have x less than -4. Then the solution set is x less than -4 or x greater than 8. If you draw this set in a line graph, it will look like this. -4 is not in the interval. That is why we use parentheses here. And x less than -4. That is why we shaded it here. Here also 8 is not in the interval. That is why we use parentheses here. And we mark all the values which is greater than 8. That is how we solve an absolute value inequality. I hope in this lesson you get an idea about linear inequalities and absolute value inequalities, and hope you enjoy the lesson. Have a great day.